Good morning, friends. Myself, Manish Kumar, presently working as a lecturer in architecture at Government Women's Polytechnic Patiala. Today, we are going to discuss architecture of hot and humid climate. Let's start with the general. We all know that our habitat, buildings, etc., are greatly influenced by many factors, and the single most important factors amongst them is climate of that particular region or area. Climate plays major role in deciding the architecture of any area. So it is very important for an architect to know about the different regions and their climatic characteristics so that he or she can plan accordingly and efficiently. Hot and humid climate. This type of climate is seen along equators. It prevails around 15 degrees from equators in the northern hemisphere and 15 degrees from the equators in the southern hemisphere. Here in this slide we can see the world map, and these blue colored countries are of this type of hot and humid climate. In this comes Sri Lanka, Malaysia, Thailand, and some parts of the South American countries. In India, this type of climate can be experienced in some parts of the Gujarat, Maharashtra, and almost all coastal areas of South and whole of the northeastern states. In this we can see this dark color, some parts of Gujarat, this whole coastal belt, and this again coastal belt, and almost all the northeastern parts of India. Now we will come to the characteristics of hot and humid climate. This single picture shows almost all the characteristics of hot and humid climate. We can see these two pictures here, sweating, extremely sweating, and hot sun, and even fishes are sweating. So it's a complete picture showing hot and humid climate's characteristics. So first we will discuss temperature. In this type of climate, the temperature is usually not very hot. Maximum temperature varies between 25 to 30 degrees, and minimum temperature varies between 20 to 25 degrees. The difference between day and night temperature is very low, and even there is a very little variation in seasonal temperatures, or we can say that temperature remains almost constant throughout the year. Second characteristics is humidity. Humidity is very high. It generally varies between 60 to 100%. Most of the time throughout the year it remains at around 75%. This results in very sticky conditions. Next characteristics is precipitation. Precipitation is very high. It may vary between 2000 to 5000 millimeters per year. Sometime in single month it can go up to 500 mm. Our Here in this slide we can see building completely surrounded by waterlogged area. This is a result of high precipitation. Next characteristics is sky conditions. There is never a complete clear blue sky because of clouds. Most of the time sky is cloudy, covering almost 50 to 90% of the sky. There are radiations and glare from sky. Next, solar radiations. Solar radiations are very less, as some of these are reflected by clouds and some of these are scattered by clouds. But even then there is a glare because radiations cannot easily escape into sky due to presence of cloud covers. Yeah, basically clouds prevent radiations to escape into sky. Next characteristics of this type of climate is wind. Wind speed is very slow near the ground due to heavy vegetation. Second, there can be very strong high speed winds for very short periods. Directions of the wind is almost constant, that is, it does not change directions. Wind is heavy and moisture content is very high in it. Yes, next is soil and vegetation. Soil is wet and loose. Vegetation grows very easily. Almost all type of vegetation grows very easily. Water table is usually very high. Ground may be waterlogged. This slide shows green vegetation. We can see almost all the ground is covered with green vegetation. Here we can see dense trees. Next, what should be the aim of architects in this type of climate? What are the thrust areas to focus? First, architect's main aim is to capture as much breeze as possible. This is the most important point. Our main aim should be to capture as much breeze as possible. Second, dissipation of building heat and human heat. Next, protection from glare. This is also very important point, as there are a lot of clouds, so there is a glare from clouds. Next point is protection from heat and radiations. All this can be achieved to some good extent by taking some suitable measures. Yes, we can solve almost all these problems. So let's start with rural settings. This slide shows rural setting in this type of climate. We can see this is a thatch roof which protects from extreme hot, and see the eaves extended very close to the ground. This gives them protection from glare and drains rainwater easily. This side is almost open. This must be the windward direction to allow wind to freely come into the house. This is side view of this structure. As we can see, eaves are going very down, very close to the earth. This protects from glare. This is second slide showing traditional rural house. Here in this we can see a sloping roof to drain off rainwater, big openable windows to capture breeze, and plinth level is raised. It is raised to protect from precipitation effects, rain, waters, etc. And we can see the walls. Walls are also very thin and locally available materials. Here they have used bamboos, thatch roof, and small concrete structures to raise the height. Next, design criteria and planning concepts. What should we keep in mind? First, we will start with site. First point, it should be as high as possible from surrounding areas to capture breeze and to provide protection from rainwater, etc. This is very simple, straightforward point. Our site should be raised so that we can experience, we can have good breeze, and this will protect from rainwater also. Second point, slope of the site should be able to quickly drain off the surface water. Yes, there should not be any stagnation of water. Water should drain quickly, so there should be a good slope so that we can guide water to go to sewers or to the nearest river. This slide showing raised site to capture breeze. This is a simple graphical representation. We can see, say this is site, so our building should be somewhere here, highest point. This will allow wind to come in and rainwater will drain off quickly, so we will have a comfortable situation in our house. Next point in the site is there should not be any stagnant water around the site. Yes, as there is humidity is already very high, if there will be water, our humidity will increase further, so there should not be any stagnant water. Next, high stem clearance dense vegetation is preferred. Yes, this is also very important point. Vegetation is good, but if it is it's clear, stem clearance is high. If there is a good stem clearance, this point will be clear from this slide. Yes, in this slide showing how high dense vegetation will provide protection from glare and allow breeze to come in. We can see this is our house, these are trees, we can see very good stem clearance. We can see these here, these are long stems, no foliage near the ground, all foliage is high up here. This will provide protection from uh, glare, sky glare, and allow breeze to come into the house. Second point is, after site, second point is orientation. First point, north-south orientation best suits for this type of climate as it protects from morning and evening solar radiations. Yes, north and south orientation is good. It will protect our building from morning and evening sun. Second, windward orientation is considered best for this type of climate. This is very important point. Our main aim is to capture as much wind as possible. So our main aim should be to capture wind. So windward orientation is best suited for this type of climate. Third point is, apart from this, local site conditions and its surroundings also plays major role in deciding orientation. This is also important point. We should see the local conditions. Next come to house plans. Elongated plans are preferred. Elongated plans are preferred because these plans will allow maximum windows in all the rooms so that we can have good breeze inside the rooms. Outdoor living areas are preferred as wind speed is very slow in these areas, so our outdoor living areas are preferred. There should be interpenetration of indoor and outdoor areas, as this is also important. There should be flexibility in planning. Here is a slide showing elongated plans for effective cross ventilation. This is a simple sketch. We have room number 1, room number 2, room number 3. This plan is elongated this way, and this way we can provide windows here and here, 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 in room number 3 here, and this way we can have cross ventilation in all the 3 rooms. If we plan compact design here, then there will not be good cross ventilation. Slide showing elongated plans for effective cross ventilation. I think this slide explains principle of elongated plans. This slide shows outdoor living areas. We can see openness, and this is outdoor living area. This will allow breeze and good thermal comfort and produce good thermal comfort. This is interpenetration of indoor and outdoor areas. This slide shows interpenetration of indoor and outdoor areas. Here we can see this is outside, this is inside, this is inside. We can see almost there are no walls. There are very thin walls. There is no rigid boundary between inside and outside. This will allow air to move freely. This type of construction best suits for this type of climate. Sorry. Next, house plans. Third point, cross ventilation is preferred. Yes, we have already discussed it. Next point is, building should not be placed very close to each other. Yeah, this is very important points. If we place buildings very close to each other, then there will not be air circulating between them. So it is not good idea. Our building should be scattered. Open verandas and galleries are preferred. Yeah, they just to have cool breeze. This slide shows a good open veranda. Here we can see this open veranda. So we can use this for our outdoor sitting areas, living areas, and this will allow breeze to come in. And this veranda will protect these windows, and it will also protect from solar sky glare. Next point, it is always better to lift buildings on stilts. Yes, we should lift buildings on stilts as the wind velocity is little higher above the ground, because at ground there is a vegetation which basically slows the speed of wind. Heat producing areas should be separated from the other areas of the house. This here is slide showing building on stilts. Here in this slide we can see columns 1 2 3 4 5 6. Basically this complete house is lifted on stilts. uh, this here ground floor is used for outdoor living areas, and these rooms, raised rooms, will receive good breeze, good cool breeze. So this is example of house on stilts. It is also very good for hot and humid climates. Next comes roofs. Pitched roofs are preferred to provide good rainwater drainage. This is very simple to understand. We should have pitched roof. Flat roof will not drain rainwater quickly. Second, ventilated double roofs are preferred. Yes, this will reduce the heat. Next point is roofs should be of low thermal materials and lightweight. Yes, a slide showing pitched roofs for easy rainwater drainage. This is a slide showing building with sloped roof. This will help in quick rainwater drainage. Next point is wide overhangs are necessary to provide good protection from glare. Yes, our eaves should be projected so that there is less glare from the sky. Roofs should reflect as much solar rays as possible. Slide showing wider overhangs to provide protection from glare. This is very good example. Here we can see this is all wall. Here this is wall. This wall has openable windows to welcome breeze, and this structure is raised. We can see columns. This structure is raised on columns. So as this is all open, so to protect persons from glare, this is overhang roof. See, almost 6 to 7 feet projected roof. This will provide protection from glare. This is another slide showing pitched roofs and good overhanging roof. Here also we can see these are sloping roofs. These will help in rainwater drainage, and here we can see overhang of roof, which gives protection from sky glare. Next comes walls. Walls too should be protected from solar radiations. Thin walls are preferred. Walls too should be of low thermal and light material. Slide showing thin and non-absorbent material walls. Here in this slide we can see, here this is front elevation. This is it is open from here. This is a double height covered veranda. Here this is a front wall. See this wall, these are again louvered openable shutters. Here again openable shutters, louvers. See how thin the front wall is. This will allow breeze to go in, and there will be better thermal comforts inside the building. This wall is thin, lightweight, and of low thermal heat material. Sliding and folding wall barriers are preferred. Sliding and folding barriers will allow us to close or open the windows or walls as per our own requirements. If there is a good breeze, we can open. If there are heat radiations or solar glare, we can close the walls or windows. Material used for walls should be of non-absorbent type, as there is a problem of moisture, so our walls etc. should not absorb moistures. Slide showing thin and sliding folding walls. This is very good example. Here we can see this is a house, 1, 2, 3-story house. We can see roof 1, roof 2, roof 3 and columns supporting the roofs. These are columns supporting the roofs. Now look at the walls. There seems to be no walls, but there are walls, sliding and folding walls, which allows air to move freely. Air can freely move horizontally. Here also, here also, here also. We have these walls, glass walls. These glass walls are sliding and folding. We can slide them accordingly. We can close all the rooms or we can open all the rooms. This will allow very good cross ventilation and greater thermal comforts in hot and humid climates. Sorry. Next comes openings, windows, etc. First, opening should be as large as possible to capture maximum breeze. This is very simple point. In hot and arid climates, our windows were of smaller size. In humid climate, we should have a bigger windows. So our windows should be as large as possible. Second point is cross ventilations are preferred. This is also very simple and clear. Third point is fixed glass windows should be avoided as they may trap heat. This is very important point. We should not provide fixed glass windows as there will be greenhouse effect and heat will be trapped inside our buildings. Deep sunshades are required to shade windows effectively and provide protection from glare. Yes, we need bigger windows, so there will be glare from the bigger windows. So we need to protect our windows with deeper sunshades to provide protection from glare. Next point is window sill should be low so that occupants can have direct breeze for effective body heat dissipation. This is also very important. Sorry. The outer cool breeze should basically touch our body so that body heat can be dissipated. So our sill should be lower. This will also increase the size of the window. This is simple slide showing cross ventilation. Slide showing effective cross ventilation. Here we can see this is our structure. This is raised. First, this is raised to capture good breeze. Second, it is provided with huge windows so that air can go from here, go inside the building and escapes out from here. This will dissipate the building's heat and body heat of the persons. Here we can see hot air ventilation from rooms. This is another exhaust. As hot air rises, so here is the exhaust right in the middle. Hot air will rise from this point also. Slide showing effective sunshade and low sill windows. Yes, this is good slide. Here we can see this is a big window almost starting from the floor, big huge window and protected by good sunshade. This sunshade will protect from glare and this window will allow maximum air to come inside the building. Here also. Opening. Next point, ventilators should be provided to dissipate solar heat or any other type of heat trapped near the inner ceilings. Ventilators are also effective in this type of climate. Sorry. Next is screens, jalis and louvers should be used to guide and capture as much wind as possible inside the buildings. Yes, basically jalis also plays very important role. Jalis will cut the glare and but allow the breeze to come in, and louvers can be angled according to the wind directions, or these can be flexible. We can change them and capture the maximum wind inside the buildings. Slide showing a jali allowing maximum air to come inside a building. This is very good example. Sorry. Here we can say this is a jali. This cuts glare and the openings in this allows fresh air to come inside the building. This is a whole wall made out of jali. This cools the wind also. Next comes interiors. Light cool colors should be used for interiors. This is very simple, as darker warm color will give hot feeling. We should use lighter colors which gives cool feeling. Surfaces that may reflect radiation should be painted dark to reduce glaring effect. This is also very important, as there are a lot of glare, so we should paint dark any surface which may reflect radiations, like the under surface of the sunshades, etc. Hard, smooth, textured floors are preferred. Yes, hard, smooth textures floor are preferred because these gives cool feeling. Floor material should be impervious to moisture. Yes, as there are a lot of humidity, so there may be deterioration of the carpets, etc. So we should use hard floors which is impervious to moisture. Sorry. Furniture items should be light and non-heat absorbent type. Even our furniture item should be of non-heat absorbent material. Okay, next comes some of the techniques or materials for hot and humid climate. We have discussed almost all the things like interiors, walls, roofs, plans, etc. Next we will discuss some techniques how we can achieve all this. First, slide showing integration of all outside and inside areas of to create greater thermal comforts. Here we can see this is a living space. See the openness. This is open plan. This welcomes fresh air, cool breeze inside the building, which will dissipate the heat. See the thin walls, almost negligible. There seems to be no walls, but there are. Walls are very thin, openable. This will provide very good thermal comforts inside this structure. Sorry. In this slide showing ventilated lightweight second roof which can keep building little cooler. Here in this slide, just see this is a typical modern building of hot and humid climate. We can see this is in the middle. This is main usable area. This here. This is wall. This is almost dead to cut glare from this side, and these are all windows. This must be the windward side. And first this area is raised from the ground. These are vertical columns. These windows will allow maximum air to come inside the building. And see at the roof, we have again columns going from down up quite high in the sky, and here we can see again another roof which is also of very low thermal heat material. This will allow outer solar radiations to reflect, or outer solar radiations can't reach this area, this roof. So this main usable space of this building will be free from solar heat, solar radiations and solar glare. See the lightness of the roof. This roof is ventilated, so there is not any possibility of trapping of heat. There will be no heat traps. See, air will circulate in this area also. This is main roof, this is second roof, this space here is for circulation of air between two roofs. This will keep the building cool. Slide showing pergolas. Sorry. Slide showing pergolas provided to cut glare and provide comfortable outside sitting areas.